Good Tuesday to you, everybody in Gov/Com 603. Welcome to week boom 10. How are you doing? Did you enjoy modular week? Did you get a chance to relax a little bit? Let's get things started off right. At the last of this morning's coffee, much better. Now I am your sufficiently caffeinated instructor. I hope you did enjoy modular week. A little break away from all the classes, time to catch up, that sort of stuff. But we are back now with week 10. And we have this week the opportunity. See, this is an opportunity for you to put into practice a lot of the theoretical stuff that we've been learning. That is, starting this week and then through the rest of the semester, we will be applying what you've learned about empirical research to actual research processes, that is, actual tests, okay? And right out of the gate this week, we are going to do something called a regression analysis. So for this video, I'm going to explain this week's exercise. And if you have questions about what this test is and how you do it, email me and make arrangements to talk. This isn't a complicated statistical test, but it's an extremely useful statistical test. If you can learn how you do it and what it's for, it can be a handy tool in your research or your professional arsenal as you go forward. All right. But before we get to that, let me just update you on a couple of things really quickly. I'm grading your final exams through this week. There are a couple of people that had made arrangements to take the exam later. I think the latest was Friday, last week. So the way Canvas works is once I start grading the exams, then it releases the questions and the answers. And if there's people still waiting to take it, it's not fair to have the answers to the questions, floating around out there. So I just say, okay, it stays closed until everybody has taken it, but that's done. So watch for those coming through this week. Likewise, I'm finishing my grading of your discussion sections. I think I've gotten, weeks 3 or weeks 4. And what you'll notice is, so long as you answer the question and then respond, let me get to how you respond, but respond, one answer with 3 response to 3 other classmates, I'll give you the points. However, if you see a note from me, let's say, I need you to go a little bit deeper in your response. This is me telling you for this second half of the semester that, oh, hey, Jack, good point. Or, yeah, I really like what you said. That's not good enough. Okay. Now, okay, some questions are going to be easier to have a discussion about than others because, how do you find a mean or what's the mode or, okay, pretty straightforward. That I understand. But for others, if you see that note from me, take note. Likewise, concerning a note from me, all your papers are graded. You'll find 2 types of notes from me. One that will say, well, I should say 3. One said, hey, good job. You're right on track. Another one will say, okay, hey, look, you've got to fix these sorts of things. If you have questions, reach out to me. That's, I'm giving you the option. All right. But the third type of note that is, can we discuss this? That means you really need to, you need to contact me and we need to have a discussion. This isn't something that you're in trouble about. This is me trying to help you become a better researcher and writer and master student and all that stuff. I would say, I'm out of coffee. That you want to see something, sad? That's sad. That's an empty coffee cup. I would say the number 1 and number 2, the top 3 issues. Citations. This is just the business of research and research writing. If you make a statement in a research paper that's beyond the obvious, like, oh, hey, we perceive the sky to be blue, you have to give a citation. If you say, political disunity is really high in America. Okay, says who? I mean, because, and I'm not picking on anybody specifically here because there's some of you, actually a couple of you are doing this in your paper. This isn't the highest that our political disunity has ever been. I mean, the Civil War was probably the high watermark. Thus far, nobody's shooting at anybody else, and there are no states who are seceding from the Union. Okay, so you can't say, oh, it's at an all-time high, and okay, no, you got to have a citation for that. Okay, that's the first thing. The second thing is in terms of length and depth. All right, if you read the instruction sheet, many of you asked me how many pages should this section be, this section be. I was looking at the instruction sheet, and I think I omitted, inadvertently the word pages. And I say 1 to 2 long for, say, the introduction. That's how long it should be. Because remember, things like introduction, you're saying, this is what I'm going to study. And then you're starting to give the background as to whatever this phenomenon is. And you can assume that your readers have a reasonable level of intelligence, but don't assume that they have an expertise in the area that you're going to study like you have. Okay. And that brings me to my third point. There are a number of you, and you'll see this in my remarks. If you're going to, propose a research project, because this is research design. Okay. If you're going to propose a research project in which, say, you'll study, and I don't know that this is anybody specifically, but I'll just use this as an example, in which, you're going to study, say, voter turnout when the polls are, kept open past a certain time. Be sure that every term that you use and element that you discuss reflects you understand the topic. Okay, don't talk about federal elections as a democratic process, because that's not what it is. It's a representative republic, and you might say, oh well, you're really being nitpicky. No, I'm not. All right. If you sell apples, don't describe an apple as a peach, because they're both fruits, true, but an apple is not a peach. When you make mistakes like that, you undercut your own credibility. Don't do that. Okay. So if you have a, can we talk, reach out to me. You need to make an appointment. And some of you have, but I haven't heard from others. All right. So take a look at that and watch for that. Okay. Let's talk about this week's assignment. I hope you're going to find it engaging and interesting to put some of this theoretical stuff that we've been going over into actual practice. You'll see in the module, all right, for week 10, and week 9 was modular, not to be confused with module. You'll see in the week 10 module that what we're going to be doing is we're going to focus on a statistical test called a regression analysis. Okay. A bivariate regression analysis. Now, don't get thrown off by the terminology here. Bivariate, like bicycle, simply means two of something. Cyclical, like a wheel, means a two-wheeled vehicle, or tricycle, a three-wheeled vehicle. Okay. Bivariate means you have two variables. And remember, we've discussed this. What's a variable? Anything. It's a happening. It's a reaction. It's any kind of event. A piano falling off a building, that's a variable. How many people jump out of the way? That's a variable. I don't know why I'd use that as an example. I don't know, just in my cartoon brain. Okay, so bivariate means two variables. Regression analysis, this means, think of the term regression. We think of it as like falling backwards, and that's not exactly it. Think of regression as, say, one thing pushing onto another and moving the reaction. An ingress is forward, a regress is in the direction. It's, and try not to think think of a direction just in terms of movement. So like my hand is regressing, this hand is regressing this hand, but this hand is moving, still moving. Doesn't matter if it's moving this way or if it's moving this way. Okay, that's what regression means. The one thing is moving the other. It doesn't mean it's making it less, okay, going backwards. It just means it's moving it. Bivariate regression. That's what we're going to look at. And we're going to look at it using a data set that I supply to you. So there's a PDF, and if you click on it and open it up, you're going to find a a sheet there with two parts. Okay. The first part is an explanation of regression analysis, and you'll also find in the module a little link to a regression calculator, a little online calculator that you can use, that you will use to work this week's exercises. Okay, so go to that PDF online and open it up. Download it if you like. And here's what you're going to find. You'll find a little introduction about what regression is, like I've just said. Okay. And then you're going to find the outline for this week's exercises. And all of the discussion questions are built around this week's exercise. Okay. So here's the exercise. I have supplied to you a data set that is a collection of data. Okay. And this is a collection of data that some researchers pulled together concerning severe outcomes from COVID-19. Now, where did they get this data? All right. They surveyed 1.4 million cases from hospitals up and down the East Coast. A lot of it was in New York. Okay. In which people went to the hospital. Okay. They said, okay, I have COVID. I need to get some help. I'm going to go to the hospital. All right. So when they went to the hospital, then the hospital registered information about them, name, where they lived, and significantly their age, and did they have any pre-existing medical conditions. And the researchers compiled 1.4 million cases in which people went to the hospital, okay, to be seen for COVID-19. And they started noticing some patterns. And so in the table that I provide you in the sheet, what you'll see is age groups. It starts from 0 to 17 years, and then it goes to 80 plus years. And for each of those age groups, they're listed 3 times on the table. Why is that? Because what the researchers started noticing, let's just start with the first age group, 0 to 17. So little babies up to 17-year-olds. Okay. What they started noticing after they ran through the data, 1.4 million cases, was that people that had pre-existing medical conditions had much higher severity of outcome from a COVID-19 infection. Well, what do we mean when we say severity? So this was the dividing line. Someone has COVID. They're 17 years old. They go to a hospital, like, I don't feel so well. Okay. The hospital tests them, say, okay, yeah, you've got COVID. Okay. One or two things immediately happen. Number one, the hospital makes an assessment and says, you know what, you just go home, drink fluids, stay indoors, stay away from everybody. Or the hospital says, you know what, your level of difficulty of breathing is pretty severe. Your fever might be high. Okay, we're going to recommend that you stay here in the hospital. Okay, so that was the first level of severe outcome, being hospitalized. That's level number 1. Level number 2, and you'll see these listed on the charts. They won't say level, but it'll say hospitalization. So level number 2 was if they got admitted to the hospital, were they sick enough that the hospital decided that they needed to be placed in the intensive care unit that is given extra staff and observation. Okay. Level number 3 is, so if they got put in the hospital, they get put in the intensive care unit. And in the intensive care unit, level number 3 was, were they having enough difficulty breathing on their own that the hospital felt that they needed to have a mask put on, that is put on a ventilator, that is forced oxygen, pushed into the respiratory system. That was level number 3 by way of severe outcome from just showing up to the hospital. So getting admitted to the hospital, getting put in the intensive care unit in the hospital, getting a respirator, a ventilator put on them in the intensive care unit. And then level number 4, the highest level of severe outcome was, despite being put in the hospital in the ICU with a ventilator, they died. That was the severest outcome that you can get from a disease is, well, you die. Okay. So they started noticing a pattern for people in all of the age groups that the pattern broke into sort of 3 cycles. For those who had no pre-existing medical conditions, they gave you a percentage outcome of those who showed up to the hospital. So when you read this data table, this is not a data table of everybody who had COVID. This is a data table of everybody who felt like they should be seen, who went to the hospital. Now, in the early days of the pandemic, that was a lot of people because there was a tremendous amount of confusion about, what this virus was and what it was going to do to you. So people that felt unwell, like, oh, do I have COVID? I have COVID. And they went to a hospital or a critical care center to get tested. And then boom, they got put into this data set. Okay. So they noticed that it sort of broke into 3 groups. Those who did not have one of the 4 most common pre-existing conditions, and a pre-existing condition is called a comorbidity. Comorbidity means it's happening at the same time. Morbidity means it's a disease, it's a dysfunction. And the 4 most common comorbidities across the population, COVID or no COVID, are type 2 diabetes, which makes up about 98% of diabetes cases. I mean, type 1 is a genetic condition. You're born with it. Type 2, you acquire as you go along. Okay. That was the first. The second most common comorbidity is cardiovascular disease. That is some arteries that are occluded or a heart that doesn't function well or both. The third was chronic lung disease, that is reduced capacity to breathe well, whether it's actually a disease going on like emphysema or just a low lung capacity. And then the fourth most common comorbidity is renal disease. And renal disease, it's a full circle here. Renal disease, the most common cause of renal disease is diabetes, ongoing diabetes. Okay, that's just not treated well. Okay, so these are the 4 most common comorbidities that the researchers found among those 1.4 million people who showed up to some type of a healthcare facility, then were admitted to a hospital. That was the first severe outcome. Okay, so when you look at the data set, you'll see 3 entries for each age group. Now, what does that mean? Well, what that tells you is for the first entry of the age group, let's take the 0 to 17-year-olds. So look at the table, and the first column after the age group says comorbidities. The first entry, 0 to 17, who had 0 comorbidities, those who were 17 years or younger that showed up to the hospital and said, oh, hey, I don't feel well, and they tested positive for COVID. 2.3%, 2.37. So let's say 2.4% were hospitalized. Of those who were hospitalized, 0.4, less than 0.5%, were sent to the ICU. Of those who, these are compounding severities. Of those who were sent to the ICU, 0.1 went on a ventilator. And of those who went to get tested, ended up in the hospital, ended up in the ICU, ended on a ventilator, 0.04. So less than, 1/10 of 1%. I mean, and this could be like 0. It's within the margin of error. It's within that confidence interval. Died. All right, that's for people who are 17 years or younger with no comorbidities. But look how the number changes when you go to let's just jump to the third entry, 0 to 17 years with 2 or more, let's say 2+ comorbidities. All right. Those that went and got tested, like, oh yeah, you got COVID, who were put in the hospital, they looked sick enough to go to the hospital, goes from 2.37% to 48.78%, 49%, just about a coin flip, nearly half. Those that got put in the hospital 19.5, so 20%, almost 1/4 of those that went to the hospital had 2 or more comorbidities, end up in the ICU, and then on to ventilators, and then death, so on and so forth. So what you'll notice is when you're looking at this data set, even before you run any tests, is there is a tremendous jump in the rate of severe outcome depending on comorbidities, whether it's 0, 1, or 2 or more. Now, why did they stop at 2 or more? Why didn't they go no comorbidities? Because they list 4 comorbidities. Why didn't they go 0, 1, 2, 3, 4 and enter all the age groups 4 times? Because what they found is if you had 2 of these comorbidities, the outcome, whether if you had 2 or if you had 3 or had 4, was the same. The tipping point for a real change in the severe outcome was 2 of these comorbidities, at least 2. And that could be type 2 diabetes and accompanying renal disease, type 2 diabetes and difficulty in breathing, and so on and so forth. Okay, you understand? That's the data that you have to work with. Now, what are you going to do with the data? Well, here's what you're going to do. In the module, there's a link to a regression calculator. And on that sheet, there's a little exercise for you. Okay. What you're going to do is you're going to pick an age group, whichever floats your boat. All right. And then you're going to look at the number of comorbidities. So let's say you pick the age group, and the one that I give you in the example is 40 to 49. Okay, so age group 40 to 49, and then you look at the number of comorbidities 0, 1, 2. Okay. And you go to that little regression calculator and just click on the link. It's an online thing. You don't have to download anything. Okay. And in the X column, okay, because you're going to create a graph where it's X and Y. Okay, or the machine's going to create it for you. In the X column, you label that as comorbidities by age. So put in your age group. Okay. And then put in 0, 1, 2. And then I want you to pick one of the severe outcomes. So hospitalization rate, placed on a ventilator, placed in the ICU, death. The choice is up to you. And I want you to, in the Y column, okay, I want you to label that. And in the example that I give you, I picked the rate at which those who were 40 to 49 that had 0 comorbidities, 1 comorbidity, 2 or more, the rate at which they were put on a ventilator. Right. And so from the table, I go to the 40 to 49. Okay. And I look at the rate for 0 comorbidities that they got put on a ventilator. Right. And so looking at the table, that rate is 0.41. So I type that in the vertical column that says response Y. Okay. So I give it a name up top, right? So my X, I'm going to name comorbidities with the age group. All right. And then in the explanatory box, which runs vertically, I'm going to type 0, 1, 2. And then for the Y, I'm going to give it a name, and I named it percentage of vent rate, meaning ventilator rate. And then I'm going to enter the percentage for no comorbidity, 1 or 2. Okay. And you could call it 2+, but just use 2. It simplifies. It doesn't confuse the machine. Okay, so looking at the table, those who were 40 to 49, who showed up at a hospital, said, I'm sick, and they got entered into the hospital, and they got put into the ICU, and then they got put on the ventilator rate. They had no comorbidities. That was 0.41. Those who had 1 comorbidity, that number went up to 3.26. Those who had 2 or more comorbidities, that number went up to 9.6. Now, remember, that's 9.6% of those who got put in the hospital. Okay. And then what you're going to do on your little calculators, you're going to click the box that says include regression line. And then you click calculate. And you're going to get a very simple scatter plot because there's only going to be 4 points on it because you've only 3 points because you've only put in 0, 1, and 2. But you're going to see a line. Okay, the calculator will give you a line. And what you're going to look at, that line, I'll tell you already, that line is going to be ascending vertically from left to right. Okay. And what you're going to look at then is the percentage of ventilation rate, those who got stuck in the ICU. Okay. From zero comorbidity to, and the way the calculator runs it out, it figures, okay, well, half of a comorbidity where there's really no such thing, one comorbidity, two comorbidities. And you'll see, it'll put those little dots on there. And you're going to see a trend. You're going to see a trend that indicates how having a certain number of comorbidities increases the rate of being put on a ventilator or dying, whichever of the severe outcomes you pick. And then you're going to get some numbers underneath it. You're going to get a correlation rate, which is represented by R when we talk about regression analysis. And then you're going to get an R squared rate, right? And those are percentages expressed as decimal points. So for the example that I gave you, okay, the correlation is R equals 0.9786. Okay, well, that's a percentage expressed as a decimal. And how do you turn a decimal into a percentage number where you times it by 100? That is, you just move that dot 2 points to the right. Okay, so that's 97%. And then R squared is 95%. Okay. So I'm not going to tell you, because I want you to look this up and read about it. What does R and R squared signify? What does it mean? All right. In regression analysis. I don't want to give you everything. It wouldn't be any fun. All right. And then in that same document, there's an article that I wrote. I wrote this for the newspaper. Where did I publish? The Epoch Times. Back in 2022, that's why it says copyright 2022, in which I tell you about an experience that I had while out hiking in Yellowstone in the year 2020, how surprised I was by that experience, and how this got me thinking about COVID-19 and comorbidities and what we were or were not doing by way of public health policy. Because that brings us right back to where we are in this class, because you're in the School of Government. And the question is, when we're governing each other, and presumably we want the best outcome for those that we govern, what kind of information do we give them? What kind of empirical research do we do? That is investigation, not advocation. And you'll see that sometimes a comment in your paper: be an investigator, not an advocator. What kind of investigation do we do into the data that leads us to the conclusions for the best advice that we can give, in this case, the public regarding their health and disease? And then one of the discussion questions you'll see is I ask you, now recall back to 2021, and that may seem like a million years ago. And I'm going to ask you, what kind of media focus, and whether this was information released from the government or just stuff put out by a media entity, what kind of media focus concerning COVID and severe COVID outcomes do you recall seeing? I mean, maybe you didn't just see any, maybe just like, okay, I've had it with this, I'm tuning out, but think back a little. Okay. Does that make sense? If you do not understand the process that is bivariate regression analysis, contact me. But I want you to try the exercise first. Read through the article, look at the data table, use the online calculator. Okay, see what you come up with. I mean, I'll give you a preview. Your line should move vertically from left to right. If you get a line that's going another direction, you did something wrong in terms of how you put your information in. Okay. I'm not going to tell you what the line is going to look like, and I won't tell you what your R squared, your R and your R squared are going to equal, because I don't know which age group and which severe outcome you're going to pick. That will affect those values. All right, but go ahead and run through the exercise. This is a great little tool that is bivariate regression analysis that demonstrates causation. Okay, because what those values R and R squared, I guess I am going to tell you a little bit about. They're going to give you percentage of how much of this, that is the outcome, was caused by this, that is the input, this variable to affect this variable. Okay, everybody. All right, longer video than usual, about half an hour here. So we're going to wrap up. Keep doing what you're doing. You're doing good. All right. We passed the halfway mark now in the semester. So we are on the back side. Right. Remember, if you got a note for me about your paper, please make an appointment with me. Good luck with this week, this module this week. I think about you. I do pray about you. And I will see you on Canvas. Bye-bye, everybody.